Experiment 7 covers solutions. Let's start with a definition. A solution is a homogeneous mixture, and it's mixed on the molecular level. The particles that are dispersed are small, just one molecule or ion each, and each one is surrounded by the solvent molecules. This is clear. You can see through it, not cloudy. An example of a solution is apple juice. We usually think of solutions as being liquids, but they don't have to be. They could be solids or gases. For example, the air is a solution of nitrogen and oxygen and some other gases. The solute are the particles that are dispersed within the larger, more abundant component. So in apple juice, for example, sugar is one of the solutes. The solvent in apple juice is water. Water is a very common solvent, but it's not the only one, for sure. It is very common in chemistry, though, and in biology it's very common. Two other types of mixtures that involve larger particles that are dispersed are the colloid and the suspension. So in a colloid, the particles are a little larger, and they may be just very huge molecules like proteins, or they may be little chunks of solids where you have more than one atom or more than one molecule in each piece. But these are suspended and they don't settle out. An example of this is milk. It is so cloudy, usually you can't see through it very well at all. A suspension has even larger particles that are dispersed, and they're big enough that if given time, they will settle out. So let's talk about two examples of this. I used to use Italian salad dressing as my example of a suspension. But things have changed. There are two types of Italian salad dressings. The old-fashioned type, the spices will settle out, and those are a suspension. And some of the newer ones, especially like the non-fat ones or whatever, they stay well mixed. And so those are colloids. There are also medicines that exist as colloids or suspensions. You may think of some medicines that are liquids and cloudy. Some of the children's medicines over the counter that are cloudy, and you don't have to shake them before you use them because the medicine stays well mixed. Those are colloids. And then you may think of some medicines that you have to shake up before you use because the medicine settles to the bottom. The one I can think of is the syrup or the liquid amoxicillin is one that used to be around. But anyway, so sometimes medicines are solutions for sure, and sometimes they're colloids and suspensions. Brownian motion is how the colloid particles stay mixed. If we have a colloid, what keeps those particles mixed is the fact that there's random motion of the solvent in here. And the random motion of the solvent causes the bumps around the colloidal sized particles. And so everything's kind of in motion. It's kind of like these particles are small enough that the wind, you can think of it like wind keeping dust up in the air, the movement of the solvent keeps them up in the solution or up in the liquid, well mixed. A suspension has that, but the particles are big enough that they still settle. The Tyndall effect, larger particles can scatter light. So this light scattering, we think of that with colloids, but suspensions will do this as well. And if they scatter light, it means that you see cloudiness. They look cloudy. Now, it is true that sometimes you have a mixture and it doesn't really look cloudy to the naked eye. Say you have an aquarium and it looks like the water is really clear, so you think, oh, that's a solution. That's one key to knowing whether it's a solution or a colloid, is that if it looks clear, you can see through it, that means it's a solution. However, the real test is to shine a light through it. And if you see that beam of light traveling through the mixture, then it tells you that it is a colloid. In a true solution, you do not see the light passing through. Solubility, how much can dissolve? Now, some solutes can dissolve at any concentration. There's no limit. Like if you put alcohol in water, you can mix them in any different ratio. But usually there's a limit to how much will dissolve and be stable. Okay. The limit is what we call when you have a saturated solution. A saturated solution has that maximum amount and it is stable. Nothing will settle, of course, but also nothing will crystallize. Everything will stay in solution when it's left alone. The way to get a saturated solution, or one way to get a saturated solution, and you're going to do it this way in lab, is that you add your solute. We're going to add salt to water. You add it, and you stir and stir and stir until it dissolves. And then you add more. And then you stir until it dissolves. And you do this until you add some, and no matter how much you stir, you can't get it to dissolve. It stays there. When it stops dissolving, and actually it's not quite stopped dissolving, when it appears that it stops dissolving, then you know your solution is saturated. When we want to give you a saturated solution of salt water, we pretty much dump so much salt in there that it just won't all dissolve, and so you'll see some solid in the bottom, and that way you know the liquid over it is saturated. What I said just a second ago about it didn't really stop dissolving is that really what's happening is that it's dissolving and crystallizing at the same rate. And we get into that a little bit in the lecture part of the class. I don't usually mention it a whole lot in lab, but it appears that it's no longer dissolving. There's no net dissolving. Okay, so that's saturated when you have the maximum dissolved. When I first learned of the supersaturated solution, I was kind of frustrated because I thought, well, didn't you mean it when you said that there's a limit to solubility and that you're at that limit when it's saturated, and now you're telling me that you go beyond that? Well, what I didn't understand is that a supersaturated solution is not stable. The solute will come out of solution if it's given a chance. And also I didn't understand that you have to play a trick to get a supersaturated solution. The usual trick is to change the temperature. You'll never get a supersaturated solution by stirring alone. You can only get it to saturation. The way you get it to supersaturation is you warm up your solvent. You know that when it's warm, you can get more solute to dissolve. Just like in warm tea, you can get a lot of sugar to dissolve. Then, after you get it saturated at a hot temperature or a high temperature, you cool it. And once it cools, now it's suddenly supersaturated. It has too much dissolve given those conditions, that temperature. This sometimes happens when people make really sweet tea. If you add a lot of sugar when it's warm, and then later you put it in the refrigerator, you may notice that there's wispy white stuff at the bottom. That is sugar that's come out of solution. This is also used to make rock candy. They saturate a solution and then they cool it, and they add little sugar sticks for the crystals to grow on so that it grows in big crystals rather than as coming out of solution like a powder like it does in the tea. Okay, one last definition is electrolyte. An electrolyte is a compound that, when it's dissolved in water, it produces a solution that conducts an electric current. And I know in biology, they will just call any ion an electrolyte, and that's fine. But we kind of extend that and say that this is an electrolyte, because when I put that in water, its solution will conduct a current. So both of those are really true. Let's look at an example of why this occurs. We'll just use salt. If I take the solid salt and put it in water, what happens is that it breaks apart into ions. And the ions are why it conducts a current. In a way, we could say each of these is an electrolyte. But we chemists would call this an electrolyte because when you do put it in water, it conducts a current. So ions are the key to being an electrolyte. We'll be talking about that later. That's why they conduct a current. I should tell you that an electric current is the movement of a charge. And that's why you need ions for a solution to conduct a current, because they provide the charge that can be moved around. In like a wire, like a copper wire or whatever, if electricity is passing through that copper wire, it's usually just electrons that are moving from one end to the other. They're the way the charge gets moved. But in a solution, you need ions to do that. And here's that definition. This is, we are ionizing the sodium chloride here when we put it in water, and that happens automatically.